So here's something that's, I don't know if you care, but here you go. This is one of the times where I'm being very specific in saying that there's a lot of stuff that we do that they're tools. And if you're going to calculus, you're going to use some of these tools. But very specifically, I'm going to introduce radians and we're going to talk about it. But it is a kind of a giant piece, or it is used a lot in calculus. And here's why. We talk about a thing called radians, which are just a different type of measurement, because here's what, you don't have to write this down. Degrees aren't real. They're fake. Well, not really fake. They're really a percentage. And it's those stupid Babylonians and their love of 60 that instead of saying out of 100, like 5%, 10%, that we do everything out of 360. So here's the problem with degrees. If I went and I told you, man, my husband's out of town, he took Thomas back to Cal Poly, and I ate 180 degrees of a pizza, well, you're either going to say, well, that's not very much, because if it was a personal pan pizza, I only ate like half of it. But if it's a large family size pizza and I ate half of it by myself, yeah, that's a lot of pizza, because 180 degrees is not it's not a true measurement. It is, hey, Jace, it is 180 out of 360. It's called a relative measurement, right? It doesn't give us an idea of how much something is. If we want to actually know how much pizza, or in this case, let's talk about pizza crust, right? So there's a place in Clayton, I don't know, it's like this secret pizza place, and it's called either Flywheel or Freewheel. I forget the name of it. I think it's Flywheel. And it's literally in this random building behind Safeway. And it's genuinely the best pizza I've ever had. And if I want to know how much crust I ate, because the crust is like handmade, they make their bread, I could figure that out, right? How much crust I ate. Here's what I would do. You learned this back in geometry. As long as you know how big your pizza is, if you're like, oh, it's a 10-inch pizza, then I would say 2 pi r. And in this case, the r would be 10. I could literally figure out the exact amount of crust I ate. It's a real number. It's not a pretend number. It would tell you exactly, wow, you ate a lot of pizza, Mrs. T, or you didn't eat very much pizza, right? Because it's a true number. When we do it with geometry and we learn how to do it, 2 pi r. Now, here's what. That's a whole circle. That's called the circumference. It's 2 pi r. But because we're doing the unit circle, this turns into 1. So going all the way around a circle in trig is going 2 pi times around a circle, or about 6.28, right? It's a real number. It's a genuine, honest to God number, right? So in calculus, when you're doing real things and you're going to be finding the area of real stuff, you're not going to be using degrees. You're going to be using radians because they're more real. So that's what we're going to talk about today, is how do we break our big circle down like we have degrees? How do we break it down in little radians? And it's not bad to do. It's pretty easy because there's a nice pattern. Are you guys with me on that? So that's what a radian is. A radian is, I'm going to say this, it's a measure of arc length. And you don't need to know that. And you know what that is? Think about this. It is pizza crust, but it's a real number. It's a genuine number. Like you could literally take a tape measure and it would really, really work. So it's a real number, and that's what a radian is. You can actually sometimes do problems on your calculator in radians because you've got a button. Remember how I said, oh, make sure it's in degrees? Your calculator has a radians button. So sometimes you can convert from radians to degrees, but we're going to do it without a calculator because it's pretty easy, right? So our job is going to be to do this. It's going to be to fill in this thing. But you know me, diving right into something, it's too hard. It's too overwhelming. So we're going to split it up, and I want you to have a whiteboard pen. I've got a few others up here if people need some. If you're stuck, I got a couple up here. You can come grab it. But I would like you right now to start right here to draw yourself a circle with the X in the middle of it, right? So there you go. Purple it is. There you go. Are you ready? I know. Well, the circle is good. It's my X. It's my axis. So we're going to split this up into two parts. And when I do this on the quiz, I would also split it up into two parts. I do one part first, take a breath, and do the other part, right? So what we're going to do is we're going to split this up into fourths, right? So we're going to take this baby right here. Actually, I'm going to split it up into eighths. And I'm going to say, okay, I've got this guy here. I'm going to throw in this guy here, and this guy here, this guy here, and this guy here. Let's start by putting the degrees on so we have an idea of where the hell we're at, right? We know this guy would be 0 degrees. And this guy, remember, he's 45 degrees. And this guy right here is 90 degrees. And this guy right here was 135 degrees. And this guy over here was 180 degrees. And this guy here was 225 degrees. I think down here we're at 270 degrees. And we're finally at 315 degrees. Did I lose anyone? No? Now we want to do the radians, right? And here's one I know. I know if I go all the way around the circle, I've done 2 pies, right? Everyone's cool with that. So if I only go halfway around the circle, guess what I do? I've done 1 pi, right? So my question is this, I'm going to split this up into quarters, into even quarters. And so here's what I want you to write down on your whiteboard desk, and then you can transfer it onto your paper. That when we're doing the 45s, the magic number here is 4. And here's what I mean. We're going to have a fraction with the number 4 on the bottom. We're going to have a pi in every one of our answers. And all we need to do tonight is figure out what goes on that top thing. And you're like, oh, that looks like it's hard. And wait till you see me do it. Are you ready? So we have done 0 pi over 4, right? We've done 0. We haven't gone anywhere. 0. Okay, be careful now. This is going to get really hard and really tricky. 1 pi over 4. Ooh, ah. How about this guy? 2 pi over 4. Oh my God. 3 pi over 4. 4 pi over 4. What is 4 pi over 4? This is 1. It's just 1 pi. Can we keep on going? 5 pi over 4. 6 pi over 4. 7 pi over 4. And if I wanted to, I would make that 8 pi over 4, but it reduces to be 2. So here's the only thing I need you to do. Before you write this on your unit circle, let's reduce wherever we can, right? So we're going to take a deep breath and make sure there's not, that we've reduced it. There's only a couple that need to be reduced. Let's find the ones that can be reduced. It looks like that one's good. Ooh, how about this one? Can we reduce that guy? 1 pi over 2, right? How about this one? We did him, right? Ooh, I hate this one. 6 over 4, that can be reduced. 3 over 2, right? I always want to make it 2 over 3, but it's 3 over 2. And I think that's it. Yeah. So could you now that you've got it, could you now put these ones in their right places on your unit circle? Yes. Probably not, but here's what, when I say find the sign of 4 pi over 3, you got to be able to find, you know what I mean? It won't show up the way you want it to show up. So that's the only thing you want to watch for. Yeah. $180 is 1 pi. So literally, would I do this Friday? Would I start by doing it on my desk and then transfer it on? Absolutely, absolutely. Your job is to make a reference thing that's from memory that's perfect, and then it's yours, and then you can use it forever and ever and ever. Amen. Right? Okay. If you noticed, we got some spots missing. We got the 30s and the 60s and the 120s and the 150s. So here's what I'd like you to do. Erase your whiteboard desk. Let's do that circle. Are you ready? So I am going to come to here and I am going to throw this guy on here. Here's this guy. Was that right? 315 is, yeah. The other one, the 135 is 3 pi over 4 or 5 pi over 4. Okay, so here's what we're going to do on this one. Big circle on your desk. Are you ready? We're going to add in some more parts here. Let's get those blue ones happening. Let's throw this guy in and this guy in. Let's throw this guy in and this guy in. Let's throw this guy in and this guy in. And let's throw this guy in and this guy in. We're going to do the exact same thing. We're going to do the math first. Take a breath. Do our reducing, and then put it on our triangle, right? Here's what's cool. This is going to check some of our math. And you're going to be like, oh my God, that one worked on both ways I did. I could do 3069 or I could have done 45. I'm like, it totally works. So here we're doing, here's what. Remember our starting point that this was 0. And when we did it before, this was pi. And I am splitting that into 1, 2, 3, 4, 5, 6 pieces. So our magical number this time is going to be pi over 6. And this is going to be the guy that we're going to fill out. And that is for the 30s and the 60s, right? That's our magical number. The magical number is the 6. Does it work the exact same way? Yes, it does. We have a little bit more reducing, yeah, because 6 is strangely a little bit more reducible. So we start off with 0 pi over 6. I'm only going to do 1 or 2 for you, and you're going to keep on going. So here we go. I'm going to, oh, real quick, that's 30, that's 60. I forgot to put this on for you. 90, 120, 150, 180, 210, 240. Ooh, there's that 270 again. I hate him. 300, 330. Okay, here we go. We're excited. So I'm gonna make them green. So 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6. Can you keep going? You do it, I'll do it. 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. Now, here's the only thing I don't like about this one. I don't think that's particularly hard. We got a few more that need to be reduced because we got more angles. So I am going to point out to the ones that you want to reduce, and you want to check with your neighbor before we transfer this on to our good one. I think this guy's going to have to be reduced. This guy, guess what? We've already done him. He's on our circle already. But you could double check it, make sure you get the same answer. This guy has to be reduced. Look at this. That's pi. He's already done. This guy has to be reduced. This guy has to be reduced. And this guy has to be reduced. That's the only thing that's a pain in the ass. You got to reduce those ones. So take a minute and reduce them. Are they hard? No, they're by like by 2s and 3s. It's not like there's not scary numbers. It's not like I'm like in, 37 goes in there. So I would say this would be one. Oh, that's not right. I'm going to make this guy 1 pi over 3, 1 pi over 2, 2 pi over 3, 4 pi over 3, 3 pi over 2 and 5 pi over 3. How'd you do? Did you do okay? Okay, take a minute now, transfer them onto your unit circle. And you've just built, that's it. She's done. She's done, perfect. She's beautiful. You've done the whole thing. And none of it was hard. Not a drop of this was hard. You guys got this. Yeah, little gang signs. Throwing the gang signs. Cosine. Sine. Blood. Crip. I don't know. I swear someone's watching this at home. Are we good? No? Okay. We're good. No. So how do we use this? Here's how we're going to use it tonight. I might ask you this and say, hey, what is the cosine of 5 pi over 3? And you know what? It's easy. You're going to look up 5 pi over 3 and look at what the cosine would be, right? So be careful. Sometimes it takes you a minute to find it. I know that, here's what I do. I know 5/3 is more than 1, so it's going to be down here somewhere. So I'm going to look for something with a 5 in it. Oh, that has a 5 pi over 3. There it is. And I'm going to use whatever the cosine is that goes with that dude. And I know the cosine on that dude matches with my 60. So it looks like it's going to be, I think it's 1/2. Did I get that right? The cosine? So I am at 5 pi over 3 and I want the cosine, right? So 5 pi over 3 and I go to cosine. How did I do? Did you get that? So what if I wanted to know, what if you try this? How about the sine of 2/3, 2 pi over 3? What if I wanted to know the sine of 2 pi over 3? Nice. Oh, positive. Won't it be over here, right? It'd be this guy. And the be sexy, the S is, the sign is positive. Is that right? So what did we get for that one? Is it root 3 over 2? And it would be positive. Is that right? Yeah. So here's what. Once you have it on your unit circle, once you've built it, you're just going to find what you need. You're going to find what you need. And it's really super not hard, right? Sometimes with the radians, takes a hot minute to find them. That's the only thing. Now I'm going to tell you one of the last thing, and the last thing is every year I have a kid who will say to me, "I hate radians. I never want to do radians as long as I live. Is there a way to do this without ever doing radians?" There is. Now on the test, on the quest, I'm going to need you to put them on, but you literally can do a thing called conversion. In other words, you can change radians into degrees and degrees into radians. So if you get something with radians in them and you hate it, you can convert it and it's easy. Are you ready to learn how to do it? So if I am 5'3", and if I wanted to know how many inches that is, what I would do is I would take the 5 and I would times it by 12 and get 60 and add 3, 63, right? Because 12 is the important number to change feet into inches or inches into feet. If a guy told me that he's 72 inches and I want to know how tall that is, I divide by 12. The magic number, the conversion rate for my friends who are in physics is the number 12. And for us, for this, you're going to write this down, the conversion for radians and degrees is this, and here it is. And the key is to know which goes on top, which goes on bottom. It's pi and 180. So here's how easy this is. Are you ready? So say I gave you 300 degrees and I said, hey, I would like to know what that is in radians. Well, one way to do it is if you have your unit circle is just to look at 300 and match it up. That's easy. But if you lost your unit circle, here's what you could do. Do you see how this has no pi in it right now? I want my answer to have a pi. So I am going to do this. I'm going to times it by pi over 180. And watch how easy this is. We don't want decimals. We want nothing. We're just going to do a little bit of really easy math. The 0 is going to disappear from this guy and this guy. Is there a number, nice easy number, that goes into 30 and into 18, as big as you can think of? 2 does, 3 does, 6 does. 6 goes in there 5 times, 6 goes in there 3 times. My answer, 5 pi over 3. I cross canceled. I just reduced the, I cross canceled. I canceled the 6 went in there, so I divided by 6. Divided by 6. You see what you with me, Jordan? Yep. So I'd like you to try one. You guys ready? Huh? It's pi over 180, and I cross the zeros. Yeah? Okay, you guys try one. You guys ready? Here's one for you to try. I would like to know the radians for, let me think of something really good. Oh, this one is not on your unit circle. That's why this one's going to be interesting. What if I got 20 degrees and I want to know what that would be in radians? It's going to be a fraction. It's going to be a dumb fraction, and we don't care. So we're not doing decimals. We're just doing fractions. So it's missing the pi. Throw that pi on there, just like Trev and I were talking about. Put the 180 on the bottom, right? Nice cross canceling. Make it nice and easy because we're lazy. What's the first thing I can get rid of on the cross canceling? How about that zeros, right? Get rid of this dude. Get rid of this dude. Is there a number that goes into 2 and 18? 2 does, right? Answer will be 1 pi over 9. That's radians. That is radians. Huh? You could go pi over 9. Pi over 9 is fine. Yeah. Now, for your money, you don't want to go this way. You want to go the other way because you hate radians. Many of us do. So how do I do it if I want to go the other way? I'm going to show you super, super easy. So let's say I got, let's see. Oh, yeah, this one will work. But I want to, let me look back at this a little bit. I like that. 5 pi over 3. And I'm like, screw you, Miss T. I'm not doing this radian thing. I just want to know what it is in degrees, and then I'll just do it from there. You can do that. But this time, we're going to put the pi on the bottom because we want it to go away. We want to cancel it. So this time, the pi goes on the bottom. What goes on the top? 180, sure. And watch how easy the math is to do. We're going to get rid of these dudes. Get rid of this dude. Is there a number that goes into 3 and 180? Yeah, 3 does. 3 goes in there 1 time. It goes in there 60. 5 times 60. Could you convert every time if you don't want to look it up on your triangle and just use your thing? Huh? That's to find degrees. So tomorrow, when we use even bigger ones, what we're going to do is instead of going around the circle a bunch of times, we're going to convert it into degrees and then just take away 360. Really nice and easy. Is everybody okay with this? We got this? Yeah? Okay. I think I am done. Your homework is short, but let's see how you do with it. Oh, what the hell the heck happened there? Yeah, I'm going to stop. Goodbye, my friends.